Chapter 8 has to do with test, and this very first section is an introductory section to how to deal with hypothesis testing, and yet we're not actually going to do the test during this section. We will do different types of tests in later sections. So just what is it and how do I work with that? First of all, in statistics, a hypothesis is a claim or a statement about some sort of a population. So this is where they're going to do a study and they will say, you know, maybe in the past 43% of the people said such and such, but I think that 43% is outdated and I think it's more than 43% now. So more than 43% would be that it's a claim. We're making a claim about it. And then they have to test that. Now, hypothesis test is sometimes called a test of significance, because we are checking to see if they can pass and say, yeah, it's a significant feature here and that's probably true. All right, so those are just some terms. So one of the very first things we're going to do is look at how to write these hypotheses before we try to test them. Now, the null hypothesis is simply really a statement that something is equal to what it was most likely before. It generally comes from a past study. But the null hypothesis we deal with by H sub 0. And it's always equal to. When you are writing hypotheses, and that's part of what you'll have to do, is either write them or identify them, H sub 0, H sub O, we often call it, H sub O will always use an equal sign. And it will be equal to some claimed value. Even if you wanted to test that a population proportion was greater than 43%, the null hypothesis, H sub O, would be that it was equal to 43%. Now, the alternative hypothesis, which is H sub 1, the alternative hypothesis says that it's going to be different than equal to. So there are several ways that we could say it's different than equal to. We can say it's less than, or greater than, or not equal to. Less than, greater than, or not equal to. Any of those can work in your alternative, but equals is always the null. Just a little bit of practice then here. We want to state the claim and the hypothesis. So what we can do starting out is we know that we're going to have an H sub O and we're going to have an H sub 1. And you know that H sub O should say equal. We don't have any idea about this yet. So a healthcare provider saw that 48% of their members received their flu shots in a recent year. All right, so that's a proportion. Now we're looking at making testing claims about a population. If this is our percentage that we're dealing with, here's a small correction there. It shouldn't just be H sub O equals. It's got to be some sort of a parameter equals. So in this case, we're looking at a proportion. So our proportion is equal to. So maybe it's the same thing it always was, 48%. However, the healthcare provider tried a new advertising strategy the following year, and they took a sample of members to test if the proportion who received the flu shot had changed. Change doesn't mean it went up or it went down. It only means it's not the same. So then what we need to test is that it's no longer the same thing it was. And those would be our two hypotheses. Now, what is the claim? The claim has to do with what they're wanting to test. And so if we've got the two hypotheses here, but the claim would be that, like, the proportion, I know I can't really write on this, I'm so sorry. The proportion is different than 48%. Now the claim could end up being the null hypothesis, Or the claim could end up being the alternative hypothesis. You can't say for sure it's always going to be the alternative one. Because if they were saying they felt like it was still the same, then their claim would be that it was the same. But we would still have to have an alternative hypothesis. So let's look at this again. Fast food company advertises the pre-cooked weight for their burgers is on average 0.2 kilogram. The company runs a regular quality control test that involves weighing a sample of burgers to see if the burgers are too light or too heavy. If the sample mean is significantly different, then they recycle the entire batch. So what could we use for the hypotheses and for the claims here? Well, the claim is what they've said in the past. They advertise that the average weight for its burgers is 0.2 kilograms. Now, I didn't write out the whole sentence, but that is what they're claiming. So our hypothesis, though, we have to have a null and an alternative. The null hypothesis and the alternative will always involve the parameter that you're talking about, which was the mean weight. So we're dealing with mu. Even though they took a sample to test it, we're trying to test something about the population. So these are both going to involve mu, just like our other ones both involve p. We know that the null has to include equals. So this time, the null hypothesis is the claim. And our alternative is going to relate with, the other case. And here we've got significantly different. And again, it didn't have to say higher or lower. So it's not necessarily greater than or less than. It is just different than 0.2. Okay? So the claim could end up being the null hypothesis, as we saw here, but it's not necessarily the null hypothesis. It can be the alternative. So one more time for this. Lena is a college basketball player who's made 75% of the free throws she's attempted in her career. She decides to practice a new technique for shooting her free throws. Lena was curious if this new technique produced significantly better or worse. Well, significantly better or worse, one more time, we happen to have one that is just different. She tried the new technique and made 70% of 50 attempts. But what we know is that in the past, she made 75%. And that's a proportion. What is the claim here? The claim could be, since she is looking to see if this new technique produces significantly better or worse results, look at what happened here. It was only 70. So based upon the sample, we would say that the claim could have been 70, which would be less than. This one's a little bit less clear, but she's not actually asking if it's just worse. She wants to know if it's better or worse. I find it's generally easier to start with the hypotheses. So here, what was our null hypothesis? It has to be equal. So should we be saying that it's, and we're dealing with a proportion, a percentage then, are we saying that it is equal to 70%, or are we saying that it's equal to 75%? Well, you're trying to see if it's changed from the original. So that original one is the 75%. So that's what we're basing our null off of, that nothing has changed. The null is generally that there has been no change. And then our alternative could be that it has increased or decreased. And since this one, we're interested in going either way, we could simply say it is different than. Now, She did not claim it actually was higher or lower. She just wanted to know. So then she tried some. Okay? So the claim is simply that it's really different. And the reason I say that is because when she tried it, she got something different. So then she's going to run a test to see if it really made the difference. Okay. The new technique, and I'm abbreviating to help with the writing here, is different than the proportion of 75%. Let's look at this one. A city had an unemployment rate of 7%. The mayor pledged to lower the figure and supported programs to decrease unemployment. A group of citizens wanted to test to see if the unemployment rate had actually decreased. So they obtained a random sample of the citizens to see what proportion of the sample was unemployed. Okay, so we're going to have a null hypothesis and an alternate. Since we're dealing with percentages, this is P. The null is always P is equal to. And essentially what you're saying, always in your null hypothesis, is that nothing has changed. So our null hypothesis is going to be that we are dealing with 7%. However, I should not have put the equal on this next one because that is not what they're wanting to test. Now, on the alternate, we can have greater than or less than or not equal to. If the null is the claim, then you just make the alternative the opposite of it. But if the null is not the claim, then we need to make the alternative the claim. So here, the claim really had to do with what the mayor said. He said he was going to make this percentage lower. So we're going to test to see if it's lower. And that claim then will be our alternative hypothesis. So a little bit different. When we actually get into doing these tests, there's more than one way to do it, but we have two-tailed test, left-tailed test, and right-tailed test. Now you can see over here the alternative hypothesis symbols has to do with which kind of test you have. Notice that this symbol points to the right, and that's a right-tailed test. When it's not equal to it, that's what that really means. If it's not equal to it, then it's either greater than or less than. And when you think about both of those symbols, if it's not equal to, it's either less than or greater than, and that's why we have both sections. Now the little sections that are marked off, the tails, whether or not it's a two-tailed test, left-tailed or right-tailed, that is called the critical region. And the critical region is the rejection region. And if we end up, and we'll talk a little bit about what this test statistic means in just a minute. When we get into forming conclusions, there's a couple of different methods. So first of all, we're going to look at a critical value method. We've got a couple of examples for us right here. If the test statistic falls in the critical region, reject the null. And when you reject the null hypothesis, notice down at the bottom here, we are never going to accept anything. You're either going to reject it or fail to reject it. Now, what is the difference between failing to reject something and accepting it? When we fail to reject it, we're simply saying it might be wrong, but we're not sure yet. And that is very different than accepting something where you're saying, I believe this is correct. So we will never accept anything. You either reject the null hypothesis or you fail to reject it. You will have to form a conclusion that is based on the claim. It always has to come back to the claim. So we will either reject the null or fail to reject it, but our evidence will be about the claim. It's either sufficient or not sufficient. Again, we're going to talk about how to get these numbers in our next lesson, But first of all, suppose we had a significance level of alpha is 0.05 and form a conclusion about the null hypothesis and state a final conclusion that addresses the original claim. So even though it didn't say that we need to do it, you have to be aware of what the null hypothesis is. Well, we can see here it's about a proportion. So if it's about a proportion, I know that my H sub O would be about a proportion, and H sub O always has to be equals. Then an alternative, since H sub O already is the original claim, and it's not always, but it is this time, then my alternative is just that that's not true. So we're going to say that it's not 3/8. Now, if it's not 3/8, you need to consider on the little forms we just showed you, that means this is a two-tailed test. So I have two critical regions over here. Each of these critical regions then is cut off by a z-score down at the bottom, and that z-score is not the test statistic. If we have alpha is 0.05, remember that our critical z-score was 1.96 and negative 1.96. Now again, hopefully you can just remember that, but if you forget that, you can do that, get that from your calculator by talking about the area. That's where you do inverse norm and put in the 95% that's in between plus one of the tails over here. And so that would be, you would put in the area of 0.975 on the inverse norm, and it's going to give you 1.96. Now, our test statistic then is negative 1.94. So you need to think about where is that in terms of this little sketch. Negative 1.94 is actually in this area. We have not yet passed that critical value. So we're not in that rejection region. We're not in the rejection region. So we should not reject. So we are going to fail to reject the null hypothesis. Now, you will either reject it if your statistic is in the critical region, or fail to reject it. Those are your only options, and it's always about H sub O. Now, when we reject it, that is the conclusion about the null hypothesis. Now, what does that mean about the claim? Well, if we're not going to reject the null hypothesis, and the null hypothesis actually was the claim this time, then particularly what we're looking at is it seems that the evidence supports that claim. Really, our original claim includes equality. It has that equal symbol in it, and we're not rejecting it. So rather than, just like we failed to reject H sub O, you want to say that the evidence, I'm not going to write the entire sentence, the evidence is not sufficient. Those are keywords. I've got that on another slide somewhere, or I think maybe we've already seen it. The evidence is not sufficient to warrant rejection of the claim. And now I'm just going to put an ellipsis here, but it would be of the claim that the true proportion of the population is 3/8. Okay, because that's what the claim was right here. So we are failing to reject the null, and since the null was the same as the claim, we are not rejecting the claim. In other words, we don't have enough evidence to say it's wrong yet. Assume a significance level of alpha is 0.05. State a final conclusion that addresses the original claim. Now, the original claim is right here for us. But before we get to the original claim, we still have to look at what all of our hypotheses are, or we're not going to know how to make a conclusion. So our null hypothesis has to be about a proportion, and it has to include an equals. So if this one is the claim, we're going to say, then the null is actually it's just equal to it. So our alternative this time will match up with our claim that it's greater. So when we reject or fail to reject the null, our wording for the claim will be a little bit different because this is the one that's the claim. Now, since we are only testing to the right, because we're looking for greater than, I need to know this critical z. So I don't have that one quite memorized, so we're going to bring up a calculator here. So we need to find out what that z-score is. So if this is 0.05 right here, because that's alpha, then this is 1 minus alpha, so this one's 95%. So I'm wanting to do an inverse norm for 0.95 on my area. So I'm going to my distribution and option 3. Okay. Or I could do it to the right. I always forget that this calculator allows me to do this. If I'm going to do the 95, that would be my area to the left of that Z mark. Or I can just say I'm putting 5% in that right-hand tail, and that might be the easier thing for a lot of you. But they'll give you the exact same value. So 95% to the left is the same as 5% to the right. I got to go down and hit enter. And I get 1.64. 1.64. So what that does is it tells me that if I end up with a test statistic in this region, that's when I would reject. Now we look at the test statistic that was obtained, and they got a 1. Well, that 1 then is not over there in that tail. It is to the left of that, so we are going to fail to reject the null hypothesis, which means we're not rejecting this. So what does that tell me about the claim? If I'm not rejecting this, then I'm not supporting this claim. So the evidence, well, if I could spell, that'd help. The evidence is not sufficient to support the claim. So we may say it's not sufficient to support something, it is sufficient to support something, it's not sufficient to reject it, it is sufficient to reject it, but whatever the it is has to do with the claim. So evidence is not sufficient to support the claim that the true proportion is greater than 0.3. So those have to do with critical values. We would reject it if the critical value were in that critical region. The critical region is determined by the z-score that goes with the alpha. Now again, alpha of 0.05 depends on whether or not it's a two-tailed test or a one-tailed test, because when I backed up here and I had a two-tailed test, that would put that 95% in the center. That's why this number is different. So you have to consider, is it a left-tailed, a right-tailed, or a center, and get the values that correspond with that. But we don't always use test statistics to make our conclusions. We also use something called the p-value method. Now the p-value method, I actually prefer this method, but there's kind of just to help you remember it, if the p-value is low, h sub o must go. I know that's a silly little rhyme, but you can get it programmed in your head. If the p-value is low, h sub o must go. what's going to happen is the alpha that's given directly, we compare that to a p-value that we get from the test. And the p-value is the area that's to the left of your test statistic. So just kind of bringing that back to how it relates to this other one, when I got this here, my test, this area, this little red critical region, was 5.05. But since my z was to the left of that, then the area in the tail, and in this case it would have been to the right, but the area in the tail with the z equal to 1 would be bigger than 0.05. So we're really comparing areas instead of standard deviations when we're dealing with a p-value. But if your p-value is smaller than alpha, reject the null. If the p-value is low, h sub o must go. And again, just like before, we will either say there is sufficient evidence or there's not sufficient evidence, but the evidence always tells us something about the claim. And just like before, we're never going to accept either reject the null or fail to reject the null. So let's look at how a p-value conclusion gets formed. We have an alpha of 0.05, and we need to form our conclusion. We're not worried about how to get this number yet. That's going to come in a later section. But what we see is that they've done a test, and the p-value was 0.0008. All right. Now, we can't really reject the null or fail to reject the null unless we identify what it is. So even though that's not what this is about, what we know is that our null hypothesis would have to do with the mean, and the null hypothesis always includes equals. So we get equal to 71. Now that would be beats per minute. So now our alternative. We don't know what the alternative is until we know what the claim is. The claim has to be represented here. So if this is the claim, then our alternative would just be the opposite of it. But if this one is not the claim, then we have to make this one be the claim. It says the claim is 71 beats per minute. So since that's the claim, and that's the one with the equal, the claim is the same thing as the null hypothesis, which means this just has to mean, no, it's not 71. All right, so now we have our claim and our two hypotheses. What we want to do is compare the p-value to alpha. Here the p-value, which we learn how to get later, we're going to be able to get that from your calculator program, and is 0.0008, and alpha is 0.05. So this one is the lower one. If the p-value is low, h sub o must go. So this time we are going to reject the null hypothesis. Now, if we are rejecting the null hypothesis, but that null hypothesis is the claim, then we are going to say there is sufficient evidence to reject the claim. So our first conclusion is always about the null, and the second one is always about the claim. And the claim may or may not be that null hypothesis. Let's do another one. Okay, here's our claim. It says so. Original claim, the proportion of adults whose preferred beverage in a restaurant is water is less than 12%. That's the claim. I also have to make my hypotheses. So if I've got h sub o and h sub 1. H sub o has to include an equals. Here we're dealing with proportions, so it's going to be p is equal to. The percentage I'm dealing with is 12%, so that's 0.12, 12%. That is not the claim, though. The claim was that it's less than 12%. So this time, my claim will be my alternative hypothesis, and its P is less than 0.12. That's a left-held test, but I don't have to, because they gave me a p-value. Once again, I just want to compare the p-value with alpha, okay? Alpha was 0.05. The p-value is 0.1625. This time my p-value is greater than alpha. If the p-value is low, H sub O must go. It's not low this time, so H sub O does not go. So I need to fail to reject H sub O. So if I am not rejecting this one, then my evidence does not support the claim, okay? Because I don't have enough evidence to reject this, so I cannot support the claim. Now, in any case, when you make a conclusion, you could make a mistake. And we talk about mistakes in statistics as either being type 1 errors or type 2 errors. And so here you have maybe a little bit of humor in there, but just an example of it. We know for certain that this person is not pregnant, and the doctor is telling him it's pregnant. And we know for certain this person is pregnant. They're saying you're not. So what is the deal here? We'll bring this back to our null hypotheses and different things. But the idea is just that rejecting the truth is different than not rejecting a lie. Sometimes when you don't reject something, you're simply saying, I'm not sure yet. So if you don't reject a lie, that's different than accepting it. You're just saying, not sure yet. But rejecting the truth is being faced with something that is true, and you're just turning it out. That is a more critical error. And so if you think about it in terms of these pictures, there is no way that the man here would be pregnant. But even though we're confident she's pregnant, what if this were some sort of a tumor and mass that's not a pregnancy? Okay, we wouldn't understand the smiles then, but it would just be a different scenario. So in terms of statistics, if we reject the truth in terms of the null hypothesis, rejecting the null when it's true is a type 1 error. The probability of making that type of an error is equal to your alpha. So when we say alpha is 5% or 0.05, we're looking at a 5% chance that we might reject the truth. We are not dealing with beta particularly in here, but failing to reject the false one is a different type of error. If it's false, we want to reject it, but we don't want to reject it when it's true. So we would rather fail to reject when we shouldn't than reject it too quickly. Because failing to reject is just saying, I need more evidence. It's like, let's do another study. Let's check it out. And of course, if you reject it when it really is false, or you fail to reject it when it's true, you've done the right thing. Just always make sure that you are dealing with the original claim in your conclusion, okay? And that claim may or may not be that null hypothesis. Okay, so let's look at this. Miss Dudley, this is not so much statistics, but just helping you understand. Miss Dudley has 2 students. We're going to call them Greg and Laura. They have very similar papers, and Miss Dudley suspects that Greg was the one who cheated based on his past records. But she's not sure. So H sub 0 would be he's innocent. The alternative hypothesis would be he's guilty. Now, the claim she's making is really probably that he's guilty because she thinks he's guilty. So the type 1 error would be he's innocent, but she concluded he was guilty. See, she rejected that truth. That would be a type 1 error. Type 2 error is he's guilty, and she decides he's innocent. So if you just think about it in terms of that, which one would be the greater problem? It's probably much worse for her to accuse him when he's innocent than it is for her to let it go when he's guilty. This is an example of what you might see on homework about type 1 and type 2 errors. So the percentage of the population with color blindness is 8%. What would be a type 1 error? Well, first of all, in order to get the type 1 error, you kind of have to consider what the hypothesis would be always. So if this is our statement, our hypothesis for the null would have to be a percentage as a proportion would be that it was 0.08. And then our alternative, since we don't have a whole lot of other information, would just be that this is not the case. And so we would say that the percentage was not 0.08. Both of the errors have to do with the rejection or failing to reject the null, though. So a type 1 error is when you reject the null and it was true. So this would be to reject H sub O when P is actually 0.08. That's a type 1 error. A type 2 error would be to fail to reject it when P is not actually that. So rejecting it when it is true is type 1. Failing to reject it when it's not true is type 2. Now the next couple of slides really are kind of an intro into the next section. So you will see that we've done some of this so far, but we have not completed the process. When we're looking at the procedure for hypothesis tests, we want to identify what the claim is. Now the claim may or may not be our null hypothesis. And we give a symbolic form, okay, that has to be true if the claim is false, but that's just putting it in the symbols for it. We have the null hypothesis down here. The null hypothesis is where the parameter equals the fixed value. And then the alternative hypothesis does not contain the equality, so it's either greater than or less than or not equal to. So we have our hypotheses, and we've practiced some of that. Then we will have to have a significance level. Now in the practice we've done today, the significance level has been given each time, and the one that's used most consistently in this textbook is 0.05. Alpha is 0.05. Of course, 0.01 would be looking at a smaller error. If it's very important that you don't make a mistake, you want to have this small alpha, because remember, alpha is the probability of making a type 1 error. Alpha would be the probability of rejecting the truth. And in some cases, that could be really severe, particularly like think about them testing medicine. So when they're testing medicine and something critical could happen if they reject the truth, they want to use a smaller alpha level. But we will select that possibly, but more likely that information will be given to us. Then we get the test statistic. Now that's certainly not something we've figured out how to get this time. The test statistic was given to us, but we will be getting it in the future. But even given that value, we also can take it to either a critical value method or a p-value method. And we've looked at both of those. So if we had the p-value method, which we just did more recently, we are going to reject it. I'm just kind of going to go down here because where it says find the values, don't worry about the figure. I've just kind of put this on there. But when we find the values, this is going to come from our calculator. And we will reject it if the p-value is less than or equal to alpha, and fail to reject it when it's greater than. And I don't think I had the or equal to, but that's an easy correction to make. So we will only fail to reject it if the P is greater than alpha. If instead we're using the critical value method, we reject it if the test statistic is in the critical region, and we practice that. In either case, when it's done, we have to restate the decision to either reject or non-reject in terms of the claim. So up in here, we are going to reject or fail to reject the null, but we need to restate that in terms of the claim. And almost always that phrasing is going to involve there is sufficient evidence or there is not sufficient evidence, and then something about the claim. I know that this is kind of a lot of information. It can be overwhelming. I really do think, based upon what we've done, you'll be able to do your homework. So please take a deep breath, stay calm, and hang in there. You don't have a whole lot of sections left before you finish up this course. Get in touch with me if you need some help. Use the Ask My Instructor. I am happy to work with you and help you finish up successfully.